problem number 8. Problem number 8 is a piecewise function. And we have x squared minus 4. And this is for x less than 0. And this is for x greater than or equal to 0. And then the other thing that we need is they ask us to do 3 things. Find the limit from the left-hand side of f of x, find the limit of f of x from the right-hand side, and then find the two-sided limit. Okay, now the reason they're having you do this, a two-sided limit only exists if these two limits are the same value. That's just like what we said before. Now, what the d is equal to negative 4. So if d is equal to negative 4, then where do I plug that in? To the first equation. So I'm just going to graph this, and I'm going to say y equals x squared minus 4. And so if I hit trace and then I plug in negative 4, there's really no problem. It's 12, right? But what they really want me to do is they really want me to come at this thing from, so I'm going to change my, I'm going to change my x values here from negative 10 to 0. And then my y values I'm going to change from 0 to 15, I think. Well, yeah, 15 will work. Alright, so this is what we want to hone in on. Alright, so I'm at negative 5 in the x direction. So what we're saying is, what we really want to do is we want to look at x as it approaches negative 4 from negative infinity. So we go more negative, and I'm going to come in closely. Now everybody look up at the screen. Watch what I'm about to do. As I come in closer and closer, as x approaches negative 4, as I get closer and closer to negative 4, for x, what is the corresponding y value? 12. It's approaching towards 12. Now algebraically, if I just plug it in, if I say negative 4 squared minus 4, we know that that's 12, right? I've already proven it algebraically, but I want you to see it graphically. So if I come in, now I'm going to go from the right-hand side. So this is 12, right? Now if I come from the right-hand side, what does it look like? In other words, look at this, the x value. As the x value gets closer to negative 4, as we move from right to left, my y value increases and approaches 12. Okay? So the limit, I'm going to show you one more thing with the table of values. As x approaches negative 4 from negative infinity, the limit, the one-sided limit from negative infinity is 12. The limit of f of x as x approaches negative 4 from positive infinity is also 12. It also happens to be defined at 12, but it doesn't matter if it is or it isn't. Because the left-hand sided limit is equal to the right-hand sided limit, then the two-sided limit exists, and it is 12. Now, does anybody have any questions about that? I'm really surprised that you guys are asking, like, I don't know if you just want to be reaffirmed, or if you're like not understanding. I think sometimes you guys are wondering, why do we need to do the one-sided limit? Either it has a two-sided limit. Is that maybe what's confusing, or?
Yeah, I think the reason I didn't get that one is because I thought that like you had to like I just plugged in like the x squared minus 4 and the 3. Like I think the 3 threw me off.
The 3 threw you off. Yeah. They just define the function that way because And that was a silly thing to do too, because when x, that's just how they wanted to do it. It's just a piecewise function, so they want you to get used to the notation. But we know, so the confusion there is that, you know, what function do I use, and do I have to use this? No, we're just looking at as x approaches -4. So -4 is less than 0, and since it's less than 0, we can totally ignore this, right? Now, if I were to graph that, piecewise function, this is actually what it would look like. It would actually come down to about right here, okay? And then at 3, so that's what the function would actually look like. Open circle here. Do you guys see that?
Yeah.
That's what the function would look like, but we were only interested in approaching from here.
Hi, Brianna.
Hey, babe.
As x equals -4, and we found that was 12, so at -4 comma 12, and so that's what we're looking at, is we're only looking at that portion, so we could totally ignore this, right? Does that make sense?
Yep.
Okay.
Hey, Mr. Adams.